And welcome to the final section of 18.3 for precipitation. There are two objectives: compare and contrast how precipitation forms in warm clouds and in cold clouds, and then describe how rising air produces condensation. Key ideas: in warm clouds, water droplets grow by colliding with each other. In cold clouds, ice crystals grow through collisions and by gaining water vapor from evaporating supercooled water. And then precipitation falls in regions where moist air tends to rise, producing condensation. Let's begin. Precipitation is any form of water that falls from a cloud to Earth's surface. The forms of precipitation include drizzle, rain, sleet, snow, freezing rain, and hail. If you want to watch a video, an interesting video titled "What Happened to All the Snow?" go back to the notes and click on the link. Water droplets in warm clouds grow by colliding with each other. It takes about 100 cloud droplets to make an average size raindrop. On cold clouds, ice crystals grow from collisions and by using water vapor that evaporated from supercooled drops. Sometimes rain falls into a layer of cold air, becoming supercooled, and if it freezes, it's called sleet. Now, if rain doesn't freeze until it hits a solid surface and freezing instantly, it's called freezing rain. Hail is a precipitation in the form of irregular clumps of ice that grow until it becomes too heavy and falls. You can see here that the stronger the updrafts, the larger the hailstone. There's also a downdraft where the precipitation actually takes place. Now, the largest hailstone weighed 758 grams and was 14.2 centimeters, and that was found in Kansas in 1970. Do not have a picture of that, but we do have a picture of what one might look like. And this one's fairly large. Looks like just above 7 centimeters. Precipitation's type depends on the conditions as it forms and falls. Precipitation falls in regions where moist air tends to rise, producing condensation. If we take a look at this mean annual precipitation chart, we can see the different areas around the planet where precipitation occurs on an annual basis. So you see the light brown is less than 25%, or 25 centimeters, and then the purple is more than 250 centimeters per year. Even a region that is very close, for example in South America, you can see where the Andes Mountains are. One side of the mountain is very wet, one side of the mountain is very dry. Near the poles, we see many areas are covered with a light brown area or brown areas. At the poles, cold air sinks and is very dry. At the equator, air near the equator typically rises and is usually very wet and moist. Same thing at the South Pole, it's very cold and sinks. It's very dry. Now, windward versus leeward is a very important concept when you're looking at differences between places on the planet. So mountain ranges can form different regions on either side. Now, air is forced to rise at the windward side of a mountain range. As the air rises, the rising air cools, water vapor condenses, and precipitation falls on that side of the mountain. Then, as that air begins to continue to go up the crest of the mountain and then come back down on the other side, it's now drier and the sinking air compresses and warms. So you'll have a lot of vegetation on one side of a major mountain range and very little on the other. So let's look at the precipitation pattern around the Cascade Range, which runs north-south near the western coast of North America. Locate that region, and you'll notice that rain is more plentiful on the western side of the mountains than on the eastern side. So which direction does the wind blow? The wind blows west to east, bringing more rain from the Pacific to the windward side of the mountains. So areas like Seattle, the state of Washington, Oregon, California, those areas are going to receive high precipitation rates. And then you go over to the Midwest states where they're very dry and cold. Now, why would it be difficult for a desert to form at the equator? Air near the equator rises because of the high temperatures of the Earth's surface, and rising air generally produces precipitation. Implementing methods of changing the weather is called weather modification. Now, rainmaking, for example, this is where an airplane is dropping artificial ice nuclei. That nuclei is actually silver iodide, which is the most common artificial ice nuclei that's used around the planet. So they drop this silver iodide into a cloud, and hopefully it'll reach that condensation level that we talked about in the last section, and decrease in temperature so condensation can occur, and then hopefully produce rain. Now we're done with chapter 18. I'd like to show you the outline just to make sure that you can go back, add to your notes if you missed anything. So we talked about in the first section humidity and condensation. Started off with characteristics of water, humidity, relative humidity, and then how to measure it. Condensation, cooling and condensation, forming of dew and frost, and the formation of fog. Clouds, different types, cloud formation, both lapse rates, the different types of cumulonimbus formation, how layered clouds form, and then predicting the lifting condensation level. Precipitation, how precipitation forms, growth of water droplets, growth of ice crystals, and the different types and kinds of precipitation. Measuring precipitation was not in our standards, took that slide out. And where does precipitation occur? Looked at the annual mean precipitation chart, and then briefly mentioned the most common type of weather modification. If you have any questions, please ask your teacher. And a good way to practice that last section, 18.3, is to look through the section review 1 through 7. Thank you.